The absence of a 10-foot tap rule in UL 580 section 31.43 can be attributed to several factors. Firstly, there's a difference in the application scope. UL 580 primarily addresses industrial control panels, while the National Electrical Code, specifically section 240.21, B1, focuses on general electrical installations in buildings. The tap rule in the National Electrical Code caters to residential and commercial wiring practices, which aren't commonly found in industrial control panels. Secondly, UL 508 aligns with industry standards set by the National Electrical Manufacturers Association (NEMA). NEMA standards for industrial control do not incorporate the tap rule concept. Thirdly, equipment certification plays a role. UL 508 to certify equipment undergoes rigorous testing and evaluation to ensure it meets specific performance criteria. Conductors and motor controller markings are designed to guarantee safe operation within the intended application, minimizing the need for additional tap length limitations. Fourthly, UL 508 emphasizes short-circuit protection. Section 31.43 mandates the use of listed circuit breakers or fuses. These devices offer immediate protection against overcurrent conditions. This reduces the likelihood of damage or fire in the event of a fault, rendering the tap length limitation less crucial. Fifthly, consider industrial practice. Within industrial control panels, circuits are generally short and safeguarded by circuit breakers or fuses positioned close to the loads. Tap conductors are typically sized to manage the load current without causing excessive voltage drop or overheating. While UL 508 doesn't explicitly state a 10-foot tap rule, it's advisable to adhere to sound engineering practices. Make sure tap conductors are appropriately sized for the load current and comply with the requirements outlined in section 31.4. In the context of industrial control panels, the design and implementation of electrical systems prioritize safety and efficiency through various means. Firstly, conductor sizing is critical. The size of the conductor must be adequate to carry the intended load current without exceeding its ampacity, which is the maximum current a conductor can carry continuously without overheating. Overheating can lead to insulation damage, fire hazards, and premature failure of the conductor. Secondly, overcurrent protection devices such as circuit breakers and fuses play a vital role. These devices are designed to interrupt the flow of current in the event of an overload or short circuit, protecting the conductors and equipment from damage. Circuit breakers can be reset after tripping, while fuses must be replaced. Thirdly, short circuit current rating is important. Control panel components and conductors must have a short circuit current rating adequate to withstand the maximum fault current available at the point of installation. This prevents catastrophic failure of the equipment during a short circuit. Fourthly, grounding and bonding are essential for safety. Proper grounding provides a low impedance path for fault currents, allowing overcurrent protection devices to quickly clear the fault. Bonding ensures that all metal parts of the control panel are at the same potential, reducing the risk of electric shock. Fifthly, control panel layout and wiring practices are important. Components should be arranged in a manner that facilitates easy access for maintenance and troubleshooting. Wiring should be neatly organized and properly supported to prevent damage and ensure reliable connections. Sixthly, environmental considerations such as temperature, humidity, and corrosive atmospheres must be taken into account. Control panels installed in harsh environments may require special enclosures and components to protect against damage. Seventhly, compliance with applicable standards such as UL 508 and the National Electrical Code is essential. These standards provide guidelines for the design, construction, and installation of control panels to ensure safety and reliability. Eighthly, regular inspections and maintenance are necessary to ensure the continued safe and reliable operation of control panels. This includes checking for loose connections, damaged components, and signs of overheating. Ninthly, documentation is crucial. Accurate and up-to-date documentation, including wiring diagrams, component lists, and operating instructions, is essential for troubleshooting and maintenance. Tenthly, training is important. Personnel who work on control panels should be properly trained in electrical safety and troubleshooting procedures. In industrial control panels, the absence of a specific 10-foot tap rule, as found in the National Electrical Code, is compensated by a combination of factors. Firstly, the focus is on short-circuit protection. UL 500-ATA places a strong emphasis on short-circuit protection, requiring the use of listed circuit breakers or fuses. These devices provide immediate protection against overcurrent conditions, reducing the risk of damage or fire in the event of a fault. Secondly, conductors are sized appropriately. Conductors within the control panel are carefully sized to handle the expected load current without excessive voltage drop or overheating. This ensures that the conductors can safely carry the current required by the connected equipment. Thirdly, control panel layouts are designed for safety. Industrial control panels are typically designed with short-circuit pattern components located close to the loads. This minimizes the length of conductors and reduces the potential for faults. Fourthly, equipment is certified and tested. UL 500-ATA certified equipment undergoes thorough testing and evaluation to meet specific performance criteria. This includes verifying the short-circuit current rating of components and ensuring that the control panel can withstand fault conditions. Fifthly, industry standards are followed. UL 500-ATA aligns with industry standards such as those developed by the National Electrical Manufacturers Association, which provide guidelines for the design and construction of industrial control panels. Sixthly, good engineering practices are employed. Even though there isn't a strict 10-foot tap rule, engineers and designers follow good engineering practices to ensure the safety and reliability of the control panel. This includes proper conductor sizing, overcurrent protection, and grounding. Seventhly, regular inspections and maintenance are conducted. Industrial control panels are typically subject to regular inspections and maintenance to identify and correct any potential problems. This helps ensure that the control panel continues to operate safely and reliably. In essence, while UL 500-ATA does not have a specific 10-foot tap rule, it addresses the safety concerns associated with tap conductors through a combination of robust short-circuit protection, appropriate conductor sizing, careful control panel design, equipment certification, adherence to industry standards, and good engineering practices. The National Electrical Code (NEC) Article 240.21 outlines the requirements for overcurrent protection of tap conductors. These rules are designed to ensure that tap conductors, which are smaller conductors that branch off from a larger feeder or branch circuit, are adequately protected against overcurrent conditions. The tap rule is one such set of regulations. There are several different tap rules, each with its own specific requirements. These rules take into account factors such as the length of the tap conductor, its ampacity relative to the overcurrent protection device protecting the feeder or branch circuit, and the type of occupancy. One common tap rule is the 10-foot tap rule, which allows for a tap conductor to be up to 10 feet long without requiring overcurrent protection at the tap point, provided that certain conditions are met. Firstly, the tap conductor's ampacity must be at least 1/10 of the rating of the overcurrent device protecting the feeder or branch circuit. Secondly, the tap conductor must be enclosed in a raceway or otherwise protected from physical damage. Thirdly, the tap conductor must terminate in a single overcurrent device that is rated at or below the ampacity of the tap conductor. Another tap rule is the 25-foot tap rule, which allows for a tap conductor to be up to 25 feet long without requiring overcurrent protection at the tap point, provided that certain conditions are met. Firstly, the tap conductor's ampacity must be at least 1/3 of the rating of the overcurrent device protecting the feeder or branch circuit. Secondly, the tap conductor must terminate in a single overcurrent device that is rated at or below the ampacity of the tap conductor. Thirdly, the tap conductor must be protected from physical damage. In addition to the 10-foot and 25-foot tap rules, there are other tap rules that apply to specific situations, such as transformer taps and service entrance conductors. These rules are more complex and have their own specific requirements. It is important to note that the tap rules are not a substitute for good engineering practices. Tap conductors should always be sized appropriately for the load they will serve, and overcurrent protection should be provided as close as possible to the tap point. The tap rules are simply a set of guidelines that allow for some flexibility in the placement of overcurrent protection devices. UL 508A, the standard for industrial control panels, does not include a specific tap rule analogous to the 10-foot tap rule in the National Electrical Code due to several key differences in the application and design philosophy of industrial control panels compared to general building wiring. Firstly, the application scope differs. UL 508 primarily applies to industrial control panels, which are manufactured and assembled in controlled environments. The National Electrical Code, on the other hand, covers a much broader range of electrical installations in buildings, including residential, commercial, and industrial settings. Secondly, the design and construction methods differ. Industrial control panels are typically designed with short, well-defined circuits and components that are specifically chosen for their intended application. General building wiring, on the other hand, often involves longer runs of conductors and more complex wiring configurations. Thirdly, the level of supervision and maintenance differs. Industrial control panels are typically maintained by qualified personnel who are trained to identify and correct electrical problems. General building wiring, on the other hand, may not receive the same level of attention. Fourthly, the focus on short-circuit protection differs. UL 508 places a strong emphasis on short-circuit protection, requiring the use of listed circuit breakers or fuses with appropriate interrupting ratings. This helps to minimize the risk of damage or fire in the event of a fault. Fifthly, the emphasis on component certification differs. UL 508 requires that all components used in industrial control panels be listed or recognized by Underwriters Laboratories or another recognized testing laboratory. This ensures that the components meet certain safety and performance standards. Sixthly, the presence of motor controllers differs. Industrial control panels often include motor controllers, which are used to start, stop, and control electric motors. These controllers have their own specific overcurrent protection requirements. Seventhly, the controlled environment of manufacturing differs. Industrial control panels are typically manufactured and assembled in controlled environments, which allows for greater precision and consistency in the wiring and assembly process. Eighthly, documentation and labeling are emphasized. UL 508 requires that industrial control panels be properly documented and labeled, which helps to ensure that they are installed and maintained correctly. Ninthly, the frequent use of supplementary overcurrent protection differs. Industrial control panels often incorporate supplementary overcurrent protection devices, such as fuses or circuit breakers, to protect individual components or circuits. Tenthly, adherence to industry standards is emphasized. UL 508 aligns with other industry standards, such as those developed by the National Electrical Manufacturers Association, which provide guidelines for the design and construction of industrial control panels. The UL 508 standard emphasizes a comprehensive approach to safety that integrates component selection, circuit design, overcurrent protection, and environmental considerations.